Okay, this is day 3 of our Algebra 1 review for Algebra 2. And this part we are on a system of equations. We are being asked to use elimination to solve a system, and a system means that we have 2 or more equations. Now the problem when we have a system is that we have an equation that has 2 unknown variables to solve for, and you cannot get a numerical answer for x or y or any of our variables if we have 2 unknowns. So we have to get rid of one of our variables or assign a value in order to get this answer. So the 2 equations that they are giving us to make this system is x minus y equals 5 and x plus y equals 3. The elimination method wants us to add these 2 equations together, and when we add them together, we're hoping to eliminate or cancel out one of our variables. So if I like to write them one over the other, so x minus y equals 5, and my other one is x plus y equals 3. Now this is starting off with a really basic example of elimination. Again, I'm hoping that I can add them together with the signs that they have, and that when I do, one of the variables will cancel out. And this one's really nice. We add by columns, by like terms, and we make sure x's are lined up, y's are lined up, equal signs are lined up. Okay, see, our equal signs are lined up in the same place, and our constants. That's important. Otherwise, we can't put together like terms. Now, this one's, again, I said easy because watch what happens. If I do x plus x, well, that's 2 x's. Negative y plus positive y, well, that adds to 0. That means the y's were eliminated. So on this one, because they had opposite values, exact opposite values, they were able to cancel out. We didn't have to manipulate any of those equations to make it happen. And equals 5 plus 3, again, we're adding them together, is 8. See how now we can get an answer for one of our values. We can get an answer for x at this point just by dividing both sides by 2, and we get x equals 4. Now that we know one of our values, we can substitute this value into either of these 2 equations to get an answer for y. And the awesome thing is, it doesn't matter which one we plug them into, they will both yield us the same answer for y. It's pretty awesome. So just because this one was first, I will use x minus y. Okay, I'm using this x minus y equals 5, and we said x equals 4. So I'm going to plug 4 in for x. I'm going to say 4 minus y equals 5. I just substituted it in, and then I'm going to finish solving for y. Okay, here's my equal sign. I'm going to subtract 4 from both sides. So I have negative y equals 1. Okay, it's not solved for if it's negative, so we divide by negative 1 to both sides. So y is equal to negative 1. Okay, would have been the same answer if I plugged it into this equation. If you don't believe me, you can check. So our answer here is, we could write this as an ordered pair. Okay, and when you are solving a system of linear equations, you're finding out where these 2 lines would cross each other. So the solution is where they cross. We could write it as an ordered pair. The point where they cross would be 4, negative 1. Okay, moving on to another example where we have to make some changes. I have a system here on 27a, 3x minus 10y equals 14, and 3x minus 9y equals 15. Now, again, I said with elimination, we want to add these 2 equations with the signs that they have and hope that something cancels out. If you notice, my x's, okay, 3x and 3x, they have the same coefficient, but if I add them together, I will get 6x. This would make negative 19y, and this would make 29. See how if I just put them together exactly as they were, I didn't get anywhere, nothing changed. I didn't eliminate one of the variables. I still can't solve this. So that didn't do me any good. So sometimes you have to manipulate or make equivalent changes. Because 3x and 3x have the same coefficient, well, I know that 3 minus 3 would make 0. So it's really easy to just multiply one of our equations by negative 1. And what we do to change one value, we have to do to change everything in that equation. So I'm just going to multiply everything in here by -1. That makes it equivalent still. I don't like really change its overall value here. Okay, and multiplying by -1 is really easy. It just changes the sign to everything. Now we're going to put these two equations together with the signs that they now have. See, now we have 3x and -3x eliminated. This is -10y plus 9y for -1y. This is 14 minus 15 for -1. See, now that my x's are gone, I can solve for y. Divide by -1. And we're going to get y equals +1. That's our first answer. After you get your first answer, you have to remember that you have to go back and get your second answer. So you can pick either of these two equations to plug one in for y to solve for x. I don't know, I always told you guys to pick the top one just because usually just set procedure is nice. Just go to, but whatever one looks nicer to you. So we would have 3x minus 10, and there's my y. We're going to substitute 1 equals 14. Keep solving for x. We have 3x minus 10 equals 14. We're going to add 10 to both sides to move it over. So we have 3x equals 24. Divide both sides by 3, and x equals 8. So the solution for this system right here, where these two lines would cross if we graph them, would be 8, 1. All right, continuing on with more examples of elimination. On 27b, if you look at this system, you can notice that our x's do not have common or opposite coefficients, and neither do our y values. So if we add these together the way that they are, nothing is going to cancel out. So what we need is to find a least common multiple between either our x's or y's that we can get them to have in common, so that either the x values or the y values will cancel out. Now I like to change the equation if there's a variable that has a coefficient of 1. That's the easiest equation to change, because we can multiply that one equation by whatever number we're needing it to be to cancel out with its other like term. So I'm going to change that y I circled. Now what I need it to cancel out with is positive 3y. So in order to cancel out with a positive 3y, it needs to be a negative 3y, right? Opposites. So that means I need to multiply the whole bottom equation. Everything has to be multiplied by -3. I can't just change that one y. That's not how math works. Remember, we have to be fair and equal to all. So I'm going to get -6x, -3y, and -3 times +5 becomes -15. I do not need to make any changes to this top equation, so I'm just going to copy it back over it. Okay, now add them together with the signs that they have. 9x minus 6x is 3x. Right here we have positive 3y minus 3y. It eliminates, it cancels out. Beautiful. 12 minus 15 is -3. Now we're in a position to get an answer or solution for x. We're going to divide both sides by 3, and x equals -1. Okay, awesome. We are almost done. Now it's a matter of substituting that value of -1 back in for x in one of our equations. And as you can see, I'm picking the top equation. So I'm going to get 9 times -1 plus 3y equals 12. Solving for y here. That's my now unknown. So -9 plus 3y equals 12. Here's the y I'm solving for. I need to move this -9 to the opposite side by adding. So I have 3y equals 21. And always finish it off by dividing. So y is equal to 7. My solution set here is -1 for x, 7 for y. 27c. Okay, now I've got to look down, everything is aligned, and I want to cancel out either my x's or y's. If you notice, I said before I like to pick the variable that has a coefficient of 1. X and y here both have a coefficient of 1. So it really is a choice sometimes, whatever like you want to do. I'm going to choose, let's see, we've been canceling out our y's, let's cancel out x. Okay, so I'm looking here. If I want them to cancel out, they need to be opposites. This is a positive 5x, so I need this one to be -5x. So that means multiplying everything in the top equation by -5. And that will give me -5x minus 5y equals positive 15. Negative times a negative. I'm going to copy back the second equation underneath. So 5x minus 2y equals negative 50. Now we're going to put them together, okay, by columns. Negative 5x and positive 5x. Okay, if I'm adding these, those eliminate, cancel out. Negative 5y and negative 2y make negative 7y, and 15 minus 50 is negative 35. Okay, finishing it off by dividing by negative 7. We're going to get y equals positive 5. So this time we have our y answer first. Okay, now we're going to go back and we're going to plug it in. I think it'd be easier to plug it into the top original equation. So we're going to do x plus 5 for y. Notice I substituted in for that y equals negative 3. And now it's just a one-step equation. We're going to minus 5 from both sides and get x equals negative 8. So our solution here is negative 8 for x, 5 for y. Okay, coming up next we have an arithmetic sequence. We're just being asked to find the next 3 terms of this arithmetic sequence. Now, there's 2 types of sequences we've done in Algebra 1, arithmetic and geometric. An arithmetic sequence is a pattern that we find by adding or subtracting, okay? Geometric is multiplying or dividing, okay? So adding or subtracting, we just want to find this pattern here. Pretty straightforward. We can see to get from 5 to 9, we added 4, 9 to 13, added 4, 13 to 17, added 4. So to find those next 3 terms, we're just going to add 4 to 17 to get 21, plus 4 is 25, plus 4 is 29. All right, you probably saw this a lot in geometry. It says find the distance between these 2 points, 1 and 3, 9 and 9. So we're asked to use a distance formula, which I have copied down here and it's on your notes. 1 and 3 is a first given coordinate. That will be our x1 and our y1. 9, 9 will be our x2 and our y2 for maybe no other reason that 1, 3 was given first and 9, 9 was given second. 1s and 2s. We substitute them into this equation. So we're saying the distance between these 2 points is equal to the square root of x2 minus x1. x2 is 9 minus, because of the formula, and x1 is 1. And we're going to square that after we subtract. Plus the difference between y2, which is 9, minus y1 is 3, and we're going to square that as well. Okay, we just keep working our order of operations down. 9 minus 1 is 8, which will be squared, plus 9 minus 3, which is 6 squared. Now, it doesn't really affect this one, but parentheses here are important to remember that if we had a negative number inside either of these, they would become positive, okay, because we'd be multiplying it by its own self. So keep that in mind. We don't want negatives underneath this radical. Okay, 8 squared is 64 plus 36. 64 and 36 makes 100. So the square root of 100 comes out to be 10. So the distance between these 2 points is 10, let's say units, because we don't know what the labeling is. Another type of factoring that we use in algebra is called factoring by grouping. And you use this type of factoring when you have 1, 2, 3, 4 terms. So you have 1, 2, 3, 4 different terms here. And what we do here is we break it apart into 2 separate groupings, 2 on either side. And what we're going to do when we factor by grouping is that we are going to take a GCF out of each group, if you remember that from our lesson yesterday. So just looking at AX plus AY, I'm looking for a GCF, something that they both have in common. Now the only thing that they both have in common is A. So I can take out one A from each of these, and when we take out that GCF, we have to divide it out of each term. So AX, take away A, we're left with X. AY, take away that A, we're left with a positive Y. And just like before when we took a GCF out, factored by GCF, we wrap up the divisor with parentheses and we put the GCF on the outside. Then we're going to move over and we're going to look at this second grouping right here, and we're going to take a GCF out of this binomial. So the only thing they have in common is B. So we're going to divide it out of each. BX take away B, we're left with X. BY take away B, we're left with Y. wrap that up with parentheses and put that positive b on the outside. Now something really magical happens when we factor by grouping. If you've done it correctly, all right, then what is inside the parentheses for both should be exactly the same, and they are x plus y in this grouping, x plus y in the other. That tells me I've done it correctly. Now, remember factoring, we're making it be a multiplication problem again, and this is going to look like a FOIL problem. Because these were the same, doesn't mean that I have x plus y squared. It just means that I get to use it, okay, one time in my answer, x plus y. That was a kind of ugly y. And then what we do is we take those two GCFs and they like fall in love and they get married and they make their own grouping in one of the sets of parentheses. So this factored is a plus b times x plus y. And if we FOILed that back out, we should get back to the original, which we would. Okay, the same thing will happen on 30A. This is an example that has just one variable and more coefficients. Notice I have it in descending order. I have 4 terms here, working our way down by exponent. So I'm going to cut it in half so that I have 2 terms on either side of that line. I'm going to take a GCF out of x cubed plus 4x squared. And that GCF, okay, I don't have a coefficient that I can take out. Coefficient here is 1, but I can take out x's. This has 3 x's, this has 2 x's. How many can they both give? If they need to both give as much as they can only both give 2. So we're going to divide or subtract 2 x's from each of these terms. So 3 take away 2, I'm left with 1x. 4x squared divided by x squared, I'm going to be left with positive 4. I'm going to put that in parentheses. That divisor, that GCF, it goes on the outside. Okay, now looking at my second grouping here, I have 8x plus 32. What's my GCF here? Okay, I have coefficients that I need to take out or deal with. Does 8 go into 32? I like to start there. Does the smaller number go into the larger number? And it does. So I'm going to put that down as my GCF. I've already found it. Can I take out any variables? I have 1x here. 32 doesn't have any variables. They don't have it in common, so it's not part of the GCF. So I'm just taking out an 8 out of each. 8x divided by 8 is just x. 32 divided by 8 is 4. Wrap it up. Put that positive 8 on the outside. Now it's really awesome. Again, like I said, what we're checking for here, those two parts in the parentheses match. That means I only use it one time. I do not have, again, x plus 4 squared. It just meant I did this process correctly. For my other set of parentheses, my other factor, I'm taking those two GCFs and I'm letting them join up in my first set of parentheses. So factored, this would be x squared plus 8 times x plus 4. I've got a couple more examples of factoring by grouping just because I don't think this was hit very well in Algebra 1, so we'll just keep going with it. I need to factor, make p to the 5th minus 6p cubed minus 2p squared plus 12 back to a multiplication problem. So I'm going to take my 4 terms and divide them into 2 parts, and then I'm going to take a GCF out of each. If I have p to the 5th minus 6p cubed, what is my greatest common factor here? Well, no coefficients can be taken out. Okay, no number parts, but variables. I have 5p's and 3p's. We always take out the smaller of those two choices. So I can take out p cubed, 3p's. I'm going to divide it out. 5 minus 3 leaves me with p squared. Negative 6p cubed, taking away that p cubed, I'm just left with negative 6. Wrapping it and putting p cubed on the outside. Okay, moving on to my second grouping. Now, if you'll notice, I have a negative sign in front of this first term now in my second grouping. Whenever there's a negative sign here, we're actually going to make our GCF negative. Okay, that's the only time we do in this kind of thing, is if we have a leading negative coefficient. So what is the largest number that goes into negative 2 and positive 12? Well, that's going to be negative 2. And then can we take out any p's? 2 p's, no p's. They don't have it in common, so nope. So now we're dividing out negative 2. Negative 2p squared divided by negative 2 is positive 1p squared. 12 divided by negative 2 is negative 6. Now, I also know that it was the right choice to make that a negative GCF because it made these two pieces inside the parentheses match exactly. They do have to have the same signs. If I had had this be negative p squared and positive 6, that wouldn't have been done correctly. Okay, so remember 2 sets of parentheses here. My matching pieces go together into 1, and then my 2 GCFs p cubed minus 2 makes up another factored. I like to say they got married. Yay, they're happy. 30c. Hey, 16a cubed plus 8a squared minus 6a minus 3. Cut it in half. Looking at my first grouping, what's my GCF of 16a cubed and 8a squared? Does 8 go into 16? It does. So that's the numerical part of our GCF. 3a's and 2a's, we can take out 2. So 16 divided by 8 is 2. 3a's take away 2a's is 1a. 8a squared divided by its own exact self, anything divided by its own self is always 1. Awesome, we know that. And put 8a squared on the outside. My second grouping, I have negative 6a minus 3. Again, this leading term in my second grouping is negative. That means I have a negative GCF. So does 3 go into 6? Yes, it does. And I can't take out any a's because 3 doesn't have any. So negative 6a divided by negative 3 is positive 2a. Negative 3 divided by negative 3 is positive 1. Again, because these match, I know that I am on the right path. Put negative 3 on the outside. To finish this off, I'm going to make 2 sets of parentheses. Maybe one day my handwriting will get better, guys. And I'm going to take my 2 outsides together and let them join up as one factor, and then my 2a plus 1 and the other. There you go, factoring by grouping. Okay, this next problem is a bit of a trick question. We're being asked to factor x squared plus 25. Now factor again, make me a multiplication problem when multiplied out would give me x squared plus 25. Now a lot of you might be remembering from our previous lesson that we learned difference of squares, and you're like, hey, this is awesome, Miss Larson, I remember. I was paying attention. I've got 2 perfect squares right here. So you said to make 2 sets of parentheses and then put a plus sign and a minus sign in one and then take their square roots because these are perfect squares, and I've got x plus 5 times x minus 5. And I'd be like, oh, you're so good. You paid attention, but you missed a part. Because look what happens if I FOILed this out. I would get x squared minus 5x plus 5x minus 25. And when I combine those middle 2 terms, okay, they would cancel out. I'd get x squared minus 25. And what is my original problem? Remember, when we multiply back out, we should always get back to the original. And this problem is x squared plus 25. This one's x squared minus 25. So they're not the same. So I can't say that this is x plus 5, x minus 5. That was called difference of squares, meaning it had a minus sign in the middle of the solution, okay, to factor it that way. And here we have a plus sign. So then I always get some students who are like, oh, well, I got this then, Miss Larson. This is going to be x plus 5 times x plus 5. They're both positive. But when FOILed out here, I get x squared plus 5x plus 5x plus 25. And the middle two positive 5's, x's, make 10x. So now we've got this extra 10x in the middle, and my original problem didn't have that. So x plus 5 times x plus 5 cannot be the way to factor it. And then I always get someone who says, well, what about x minus 5 times x minus 5? Because 2 negatives multiplied to a positive. This would give me x squared minus 5x minus 5x plus 25. The middle 2 would combine to make negative 10x. So then I've got an extra negative 10x in the middle. So that solution doesn't work either. So I've tried everything I can think of, okay, these 3 things to give me an x squared and a 25 somewhere in the answer. Nothing works. So what does that leave us with? Prime. That word prime. This binomial actually cannot be factored, and that happens sometimes. And when that does, we say prime or cannot be factored. So now we've seen a few different types of factoring that through these last few videos, and your job this year as an Algebra 2 student is going to be, you're going to be factoring all the time, and you're going to have to be able to look at the polynomial and decide which method of factoring should be applied, because really only one should be applied to make it be done correctly. So I just want you to look at these 4 examples that I have underneath here and to be able to decide which is the correct method of factoring that would need to be applied to each of these examples. On this first one, hey, sometimes the number of terms in it helps give you a clue about which type of factoring. So my first 2 examples both have 2 terms in it. So I'm either going to be able to do difference of squares or take out a GCF. So I'm looking on this first one, 18 and 48, those are not numbers that are perfect squares. A squared is a perfect square, but it's got B that's not a perfect square. And then right here we have AB, not perfect squares either, because they, and C cubed, because they are not even exponents. So I can't do difference of squares here, but I know that they have things in common. So if you can see that they have factors or terms in common, then the type of factoring we're going to do is factoring by GCF. On this second example, I have 9b squared minus 100. You still should always check to see if things have a GCF, but these 2 terms don't. It doesn't mean it can't be factored. It's just a different method of factoring. 9b squared is a perfect square, 100 is a perfect square, and that criteria, it does have to have a minus sign in between. That's what this problem up here was missing, was that minus sign. So this would be difference of squares factoring. And that was on yesterday's video where I said to make 2 sets of parentheses, one gets the plus sign, one gets a minus sign, and then the factors that go in are found by taking the square roots in the original problem. 9b squared would become 3b when we take its square root, 100 is 10. So that would be the solution there. On this next example of x squared minus 11x plus 24, again, count the terms. 1, 2, 3, factor tree. That means I'm looking for 2 numbers that multiply to positive 24, but yet add across to make negative 11, that middle term. So those 2 numbers only can be you have to find the right 2. It can't just be any 2 factors randomly. So negative 8 times negative 3 make positive 24. They add to make negative 11. So we would write it as x minus 8, x minus 3. Okay, that was because we had, again, 3 terms. I would say that factor tree. And then this last example, we counted how many terms? 1, 2, 3, 4. This is factoring by grouping, and that was done on a previous slide in this lesson. So I'm not going to do this one. Okay, but those are the different types of factoring, and again, a lot determined by how many terms in the problem and the signs in them. Now we're on to having some really good algebra fun. I feel like these examples probably should have been done on the first day of our review because it's one of the first things we learn how to do in algebra, but we're solving equations. We're solving for our one variable. So on this problem I have 4 times x plus 1 equals 6x minus 1. I always taught you guys to find the equal sign first, and then we're looking on each side of that line, and we're going to expand and combine like terms before we start moving things from one side of the line to the other. So parentheses mean we have to multiply or distribute. So we're going to get 4x plus 4 times 1 is 4 equals, I have no parentheses on the right side, and these are not like terms, so we're going to bring it down, 6x minus 1. 4x plus 4 are not like terms, so now that we have it expanded and condensed as much as possible, we're going to start getting x's on the left, constants on the right. So I'm going to start by subtracting 6x from both sides. 4x minus 6x makes negative 2x. And then, again, I need the constants pushed over to the opposite side, so this positive 4, we're going to move it by subtracting 4. And I get negative 5. And now we're going to divide both sides by negative 2. And I get x equals, okay, negative 5 over negative 2. I'm going to say that's positive 5 halves. Now, a lot of times we get whole number answers, but not always. It can be a fraction. There we go. Okay, moving on to example 32a, solving this equation for m Now, I'm not going to lie, I'm a big math nerd. The messier the equation, the more fun I'm going to have. So again, first I need to expand and condense within each side. So I work left to right. I can see that 9's outside this set of parentheses. I've got to distribute it in just to the parentheses. So 9 times m is 9m. 9 times negative 3 is negative 27. Okay, my closing parentheses means I stop multiplying, and I'm going to bring down positive 3m. We're not using m yet, but we will in a little bit. And then I have 7m plus 43 working left to right. There's nothing to multiply, and these are not like terms, so we're going to bring them down. 7m plus 43. Okay, on the left, if you have more than 2 terms, I have 1, 2, 3, there's a good chance that something needs to be grouped together as like terms. And my like terms here are the 9m and the 3m because they have that matching variable. And because they're on the same sign, I'm leaving this positive 9m, positive 3m to make positive 12m. I'm not using opposite signs until I move to the opposite side of that line. And negative 27 gets brought down, equals 7m plus 43. Okay, now that it's just 2 terms on each side, I want to move my m's. I like them on the left. We're going to subtract 7m. Again, I'm using the opposite side now because I'm going to the opposite side of the equal sign, opposite side of that line. That's why I like having it there. 12m minus 7m is 5m. Okay, canceled out there. Now I need to get the constants, my regular numbers, on the opposite side. So we're going to move this negative 27 by adding it to the opposite side. And 27 and 43 make 70. Okay, now I have 5m equals 70, and almost always we finish by dividing. So 70 divided by 5 is 14. So m is equal to 14. Right, continuing on, 32b. My first thing that I always do is I find the equal sign. Sorry, I made that crooked. Okay, here's my equal sign. I'm going to work left to right. Okay, I have negative 16 and then minus 7. I'm not going to subtract these two things first. The only thing that's being multiplied to 2a plus 3 is this negative 7. So I'm not using negative 16 yet. We're going to bring them down. And then multiply negative 7, we get negative 14a, and negative 7 times positive 3 gives us a negative 21. We're going to look at the right side. We have 23 minus 2a, no multiplying, no like terms, so we bring it down. Okay, on the left side, I'm looking, I have 1, 2, 3 terms, so I know something needs to go together, and what is that? It's going to be negative 16 and negative 21. What do they combine with? And again, this is a negative 16, not minus negative 21, but just a negative 16 and a negative 21 that go together to make negative 37. And then bring down negative 14a. This is equal to still 23 minus 2a. Okay, 2 terms on both sides. Now it's time to start moving across that line. I want my a's on the left, so I'm going to add, do the opposite, and add 2a. And negative 14a plus 2a gives me negative 12a. I need to get this negative 37 to the opposite side, so we're going to add 37. So that's going to equal positive 60. And we're at the end of the line here, so we just divide both sides by negative 12. 60 divided by negative 12 is negative 5. Isn't that so fun? I love solving equations. Okay, moving on to this next example. Okay, a little bit more to do on each side of the equal sign, but there's my line. Okay, I like knowing where it's at. Now, 5x is, again, it's not touching these parentheses. We're not going to distribute. No. Okay, we don't do that here. We're going to bring down 5x. What we do multiply in is this negative sign. It's negative 1. Remember, we don't have to put 1 in a lot of places if that's the value. It's just implied. So I get negative x, and then negative 1 times negative 18 becomes positive 18 equals. Okay, same thing here. 6 is not touching the parentheses. We bring it down. What we do multiply in is negative 2. So I get minus 2x minus 30. So if you can look, I have 3 terms on both sides. That means there's like terms to combine within each side. My like terms on the left are 5x minus 1x, which is 4x. Bring down plus 18 equals, on the right side here, my like terms are the constants. 6 minus 30 is negative 24, and I'm bringing down negative 2x. Now that there's two terms on both sides, I'm going to get x's on the left, so I have to add 2x to both sides, and I get 6x. I want to push those constants to the opposite side, so I need to subtract 18, and I get negative 42, I believe. And so because 6x, we're saying 6 times what equals negative 42, we can find that out by dividing both sides by 6, and we get x equals negative 7. Woohoo! Okay, on number 33, it says let A equal the set 2, 4, 6, 8, and it's a set in the universe of U equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the complement of A. So we have this universe set, this bigger set right here, that's numbers 1 through 10, and then A is basically a subset of U. So that's what A is equal to. What's the complement of A? The complement is all the numbers that are like not included in A. So I'm going to show that by saying A and then this little apostrophe after it. That shows that it's the complement of A. And it is equal to all the numbers that were not in A. So I'm going to cross off 2, 4, 6, 8. So the complement of A is everything that's left over, which would be 1, 3, 5, 7, 9, and 10. Pretty straightforward. On number 34, we're asked to identify the domain and range of the following relation, which a relation is like a grouping of ordered pairs. And then we're asked to say if this relation represents a function and why or why not. So if you remember from Algebra 1 that I taught you that domain means the x values, okay, in your ordered pairs. That's all it means. Domain is the x values. Range then is the y values. So looking at this grouping of ordered pairs, this relation, the domain is going to be all of the x values, everything that comes first in each of these groupings of parentheses. So the domain here would be negative 4, 3, 2, and 5. That's the domain. Pretty easy. The range is all the y values, everything that comes second. So 5, 7, 8, and 7 repeats. Now, if something repeats, you do not have to list it more than once. So 5, 7, 8. Okay, now function is a special type of relation in which it's only a function if x's do not repeat. Remember, I told you guys that if your ex kept showing up, your ex-girlfriend, your ex-boyfriend, you'd be getting in trouble. You wouldn't function very well. So functions, we don't want our x's repeating. We don't want it showing back up. So we only look at the x values. Okay, in here in red, negative 4, 3, 2, and 5. Because those were all different, then yes, this is a function. And why is it a function? Because x's did not repeat. And if we graphed these points, it would pass the vertical line test. Okay, that's another way of showing whether or not something is a function if we have a picture of those ordered pairs or of the line that's graphed, and if it passes the vertical line test. We'll talk about that later on as well. So some extra practice on determining if something is a function or not. Again, it comes down to x's. Again, we say that why does it keep doing that? X's cannot repeat. So to be a function, x's don't repeat. So we're just answering if this is a function or not. So only look at the x values. So number 1, my x values are 5, 3, 2, 0, and negative 1. I did not repeat any values there, so this is a function. On number 2, our x values here are negative 2, 0, 2, 3, and 2. They have to be exactly matching. See, I have 2 that repeated, so not a function. Not function. Okay, so keep continuing on just really quick. Number 3, we have negative 4, negative 3, negative 2, 1, negative 3. Our negative 3's repeated, so not a function. I'm going to say not fun. Number 4, my x values are 1, 2, 3, 4, and 5. Okay, the x's don't repeat. And notice I'm not looking at the y values at all because it doesn't matter what the y values are. Okay, it only comes down to the x's. Do they repeat or not? Y's can repeat like all the day long. We don't even care. Now, these other examples just show different ways to display relations. Okay, so these first 4 examples, we had ordered pairs, 5 through 10. Okay, these we have table of values is what they're called, and then 11 through 13 is mappings. So I like the table. I feel like it makes it even easier because we're just looking, okay, we are just looking at the x values. Okay, we're just looking at that x column to determine if it's a function or not. So real quick, is this a function? Well, 3 repeated in the x column, so it's not a function. Okay, looking at number 6, just really quick, does anything repeat? What about -2 and +2? They're not exactly the same, so yes, this is a function. Number 7, looking at my x values, -5, -3, 0, 1, 2. Yes, this is a function. My x's did not repeat. Number 8, I've got 2 4s, so not a function, not fun. Okay, just abbreviating that, but I like it. Now number 9, -8, -4, 0, 4, 8. Nothing repeated. Now all the y's are the same, -1 for all of them. It's still a function, yes, because again, y's can repeat all the day long, but not the x's. That's what it comes down to. X's don't repeat. And number 10, 1, 2, 3, 4, 5. So yes, this is a function. So 11, 12, and 13 are showing relations again, but it's using a mapping, which is the 2 separate circles with arrows coming out of the x's to show which y it would be grouped with. Now, as long as the x values, a value in the x circle does not have 2 arrows coming out of it, then it's not used twice. So -3 is used once, 1 arrow, 1 arrow, 1 arrow, 1 arrow. That means each x was only used once, so yes, this is a function. On number 12, we have our x values are -4, 1, -2, and 1. But see how there's these 2 arrows coming out for -1? That means -1 was repeated. It was used twice. So this is not a function. And number 13, -1, 0, 1, and 2. Now, even though -1 and 1 both go to 2 for y, 2 is used twice. That's y repeating. And remember, that doesn't matter. All the x's are just used once. So yes, it is a function. So that's how you tell by looking at a set of values if something is a function or not. 35, we are asked to identify the pattern and give the next 3 terms in this pattern. We have 4, 20, 100, 500. Notice that we are not continuing this pattern by adding or subtracting. So the type of pattern that this would be is going to be geometric because we are multiplying to further this pattern. So what are we multiplying by each time? To get from 4 to 20, we are multiplying by 5. 20 to 100, we're multiplying by 5. 100 to 500 times 5. It should always be, to be a geometric sequence or arithmetic sequence for that matter, you have to be using that same constant ratio every time. It can't like jump to be, times 5, then times 3, then times 5 again, then times 2. You can't do that to be a geometric sequence. So we're multiplying by 5 each time. So to get the next 3 numbers in this pattern, we're going to multiply 500 times 5, and we get 2,500. And then we multiply this by 5, and we get 12,500. And multiply by 5 again, and we get 62,500. So you do have to have a constant ratio. See how this was always multiplying by 5? That meant r equals 5, and that meant we could keep continuing on the pattern in that way. Now number 36, this is some translating. We did this quite a bit. I feel like in Algebra 1, it's useful when you're working on word problems. We have to translate 3 times the difference of x and y. Now this phrase right here, times the difference of, if you remember from Algebra 1, was a parenthesis phrase. We don't want to do just 3x minus y. We're wanting to multiply. This is saying 3 times the difference of x and y. So we're going to put 3 on the outside of these parentheses, and then we have x and y inside, and difference means subtraction. So when you have times the difference of or times the sum of, it translates into like a distributive property problem. Okay, number 37, we're evaluating algebraic expressions for some given values that we're going to assign to x and y. This is something you do in all levels of algebra all the time, and it's really important to make sure that you can do this correctly. I always teach that when you are evaluating an expression, that I told you to rebuild the expression given by replacing every variable with parentheses. So if I have 3x right here, I'm going to do 3 and then parentheses for x. You always use parentheses when you substitute a value in for a variable. Okay, and then minus, I have parentheses up here because I'm going to do x over 2 plus 4 parentheses for y minus 2 parentheses for y, and then a cubed, see, outside the parentheses for y. And when you use parentheses, you just make sure you set up your calculator or yourself to do your order of operations correctly. It helps you eliminate mistakes. Now we're going to substitute values into these parentheses. We said x equals -2. So wherever there was an x in the equation, I'm going to put that -2 in for x. So -2 right here. Where else do I have an x? Another x here. And that's it. Okay, then we say that y is equal to +3. So I put a 3 in where the parentheses where every y should have gone. At this point, you can work it out by hand, but because we're in Algebra 2 and you should be really good at order of operations right now, I actually have no problem that if you can show me that this is how the problem should be set up and you knew to use parentheses, that you can just type this straight into your calculator. And especially if you got a Casio like I requested, you can type it in exactly like this and it will give you the right answer, which is -47. It's just really important, again, always when we're evaluating expressions to use parentheses to rebuild this and type it into your calculator the right way. So looking at 37a here, I have a squared b minus b squared, and we're going to say a equals 3 and b equals -4. So looking at this, I'm going to rebuild it first, just like I told you, which means I would put parentheses for a squared, then b came next, so another set of parentheses, then my minus sign, parentheses for b squared. Now we substitute in our values. A is 3, so I put a 3. Okay, that's where a was located. And then we're saying that b is -4, so I'm putting -4 here and here. At this point, that's the work that I need to see. I'm fine with you jumping to using your calculator. If you do like doing it by hand, that is super awesome, and I applaud that because I like doing that too. But please double check with your calculator because it makes no sense to get it wrong when just because of an arithmetic error. And this comes out to -52. Okay, number 37b. Okay, -y squared minus 3xy. And I threw this example on because I wanted you to pay attention to this negative sign in front of y squared. If you have a negative and then your variable, when you're rebuilding this with parentheses, that negative stays outside the parentheses. It changes the value of your answer if you put it incorrectly inside. So I have negative sign, then parentheses for y, the squared goes on the outside of parentheses, and it is important to remember to put your parentheses on, or your exponent outside the parentheses when you're rebuilding, not inside. -3, and then 2 sets of parentheses each for x and y. Okay, substituting in our values, let's see what goes in for y is -12 here and here. What we're placing in for x is -5/6. Again, calculators don't hate fractions like people do, so use your calculator if you need to. I encourage it. Type it in, again, exactly like it's shown here, parentheses, signs, everything, and you should get -174. If you're trying these problems at home for some reason and you're not getting the same answers as I did and you're using your calculator or you're doing it by yourself, you need to meet up with me so we can make sure that you know how to use your calculator correctly, and that will help you so much with so many like unneeded headaches this year. Okay, number 38 is going way back to the very beginning of Algebra 1 where we talked about each of the different properties. The properties that we have to choose from are associative, reflexive, commutative, substitution, distributive, and symmetric, it looks like. So looking at A, we have x plus 4 equals 4 plus x. Now notice on the left we have an x and a +4, and we have a +4 and a positive x on the right side of the equation as well. We just moved the order. Remember, when we moved the order, what of our word choices means to move, and I told you guys commute. The word commute means to move. So this would be commutative property. We just moved the order. We did not change any values. It is the same thing still. We just changed the order. So that's where we move things around on either side of the equal sign. Now B, we have x plus y grouped together, then plus z, and then we have x and then y plus c grouped together. But if you look at what we have here, we have x, y, z, x, y, z. We did not change the order. What we changed was who was grouped with who. X and y are best friends in the left side and z's on the outside. And then we have y and z being best buddies and x is left out. But the order itself of x, y, z didn't change. We changed who was grouped or who was hanging out with who. And I always told you guys, well, you group with like who you associate with, right? So this was your associative property or something like that. So this is associative when we change groupings but not order. So changing order is commutative, changing groupings is associative. On C, it looks like we have -8 on the outside, then a plus b inside the parentheses. Well, that tells me we have to multiply or distribute -a in, and that would give us -8a minus 8b. So that is distributive property. We multiplied that value. They equal the same thing. Notice these equal signs are saying they still equal. They have the same value. We just changed what it looked like by using a certain property. And then D, we have if x equals 2 and we say 4 plus x equals y, then 4 plus 2 equals y. So what we did was we took that x away by substituting in that 2 for its value, which was assigned in the problem. So this is substitution. Beautiful. On number 39, we're asking if this inequality is always, sometimes, or never true. Well, let's solve for x and find out. Inequality means we have a greater than or less than sign. We treat it like an equal sign for now. So we're going to work this out left to right, expanding first. We're going to multiply in 6, and we're going to get 12x plus 24. And we're going to bring down our minus 8x plus 2, which is less than or equal to 4x plus 26. I'm looking for like terms on the left. I have more than 2 terms, so 12x minus 8x gives me 4x, and then 24 plus 2 makes 26. So less than or equal to 4x plus 26. Hey, now look at what we have here. Both sides are exactly the same. So when I solve this, I would actually end up getting, it looks like, is 0 less than or equal to 0, but I can see it here as well. Well, is 0 less than or equal to 0? Yes. Is 4x plus 26 less than or equal to 4x plus 26? Yes. So is this always, sometimes, or never true? We're going to say that this is always true. All right, the quadratic formula is actually, like, it's introduced in Algebra 1, but it is actually something that it's really hit hard again in Algebra 2. So it's not necessarily an Algebra 1 skill because we will keep doing it. But a quadratic equation is when you have something like this over here on the right, where our x value is squared, okay? And a quadratic equation, we get a parabola. That's the shape of like our rainbow or our smiley face. This is positive, so it's happy. It'd be like this. So when you have your quadratic equation set equal to 0 like it is here, and you solve for x, you're finding where this parabola would cross the x-axis on a coordinate system. Again, we're going to get into a lot more detail of this later on, but those are called the solutions. And sometimes those can be found by factoring and all those different methods, but sometimes they can't, and you have to use a quadratic formula. This right here, okay, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all being divided by 2a, is a quadratic formula, which is something that you should commit to memory. I mean, I've had it memorized since I've been in high school, used it a lot in my math life, so it is a very useful equation, formula, and it's used a lot in math. So the thing that you have to know, to use a quadratic formula, formulas are awesome because we just plug values into each of the variables and we type it into our calculator. We just have to know what numbers go in for a, b, and c in that quadratic formula. Well, looking at 2x squared plus 4x minus 3 equals 0, this is how a quadratic formula is set up. Ax squared plus bx plus c, okay, equals 0. So a is the number in front of x squared. B represents a number in front of x. C is your constant. So once we have this right here, that's our guide for labeling A, B, and C. The number in front of x squared is 2, so A is equal to 2. B is the number in front of x, so B is positive 4. C is the constant, so C is negative 3. These values are going to be plugged into this formula. This is what it's going to look like. Okay, we're going to say x is equal to negative, and then my B value, okay, is 4, plus or minus the square root. Notice I'm using parentheses because I'm evaluating an expression here. B squared, so 4 squared, minus 4, then A, then C are going to go in parentheses. A is 2, C is negative 3. All of this is being divided by 2 times A, which was 2. Now this is really awesome because if you got a Casio or if you have a graphing calculator, it will let you type in this exact problem, parentheses, fraction, and everything. You type it in because you knew where everything was supposed to go based off the formula. You hit equals, you get the answer, and you don't have to work it out step by step, which is really awesome. Now the one difference is your calculator does not have a plus or minus button, which just means that you need to kind of have this calculator make changes on your calculator to do this problem 2 different ways. The first time I would use the plus sign, and then the next time I would go through with my calculator and change it to a minus sign. So you are going to get 2 answers here because a parabola can cross the x-axis 2 different times. And again, this is going to be like its own mini lessons in Algebra 2 as well. But when I type this into my calculator using the plus sign, I get negative 2 plus the square root of 10 over 2. If you had a Casio, what's nice is a lot of times we want our answer with the radical simplified, which a Casio would do, which is why I wanted you to have one. But if you didn't have one and you needed decimal, your Casio will convert this by pushing the S to D button, and this is equivalent to 0.58, and then it goes 11133 blah blah blah, keeps going on, which is why we like this form a little bit better because it's more exact. We didn't have to round, but this answer would work fine for now as well. If I changed it to a minus sign, then I would be getting negative 2 minus the square root of 10, okay, over 4. Did I say 2? Over 2 because we simplified. And this would then change to decimal if we wanted to round it to negative 2.58, which would be less exact. But a lot of times we like it like this. Simplify with the radical, which your Casio will do if you got one.